Good morning everyone. I am D. Sengotin, Assistant Professor of Physics, SNS College of Technology, Coimbatore. Today we are going to study about basics about laser. So laser means light amplification by stimulated emission of radiation. Then the properties of laser, the laser lights highly monochromatic, high intensity, highly directionality and highly coherent light source. So we all know that ordinary light that is less monochromatic, that is polychromatic source, then less intense and less directionality and low coherent. Then principles of laser, that is very simple. The stimulated emission process identify the laser light. So basically before emission the light radiation absorbed by the atoms, then the atoms moves from ground state to the excited state, that means E1 to E2 states. So number of atoms in the ground state is called N1, number of atoms in the excited state is called N2. Then once atoms moves from valence band, that means ground state to excited state, that is called absorption. Then the light energy emitted through spontaneous, that is called ordinary light. Then light energy emitted through stimulated emission, that is called laser light source. The symbol used by light energy, that is H mu. Then conditions required for laser oscillation or laser action, that means population inversion, that is N2 greater than N2. It means that number of atoms in the excited state or E2 state is greater than number of atoms in the ground state, that means N1. Then the energy density of radiation on the medium should be increased. The ratio of Einstein coefficient should be less, that is A21 divided by P21 is less than 1. A, B are called Einstein coefficient, then 21 it means excited state to ground state. Okay, this diagram shows that the energy levels, so low energy and high energy levels. The first diagram, it means number of atoms in the ground state, that is called normal state, normal population. Once the energy transfer from lowest state to highest state, that means population inversion. Number of atoms is greater than ground state to excited state, it is called population inversion. Then if we are producing laser light, these two types are very important. The first one is active medium, then second active center. So active medium, very simple, the laser light producing source, that means for example CO2 laser, CO2 acted as an active center, then surrounding helping materials are act as an active medium. For example nitrogen and helium act as an active medium, then the CO2 act as an active center. So these two different titles are very important for producing laser source. Then next, the pumping or mechanism, or the mechanism used for producing laser light. So the external energy is supplied to the active medium to excite the atoms ground state or lowest state to excited state, that means highest state. So creating the population inversion, and finally the laser oscillation is achieved. The graph, the line shows that external energy excites active center, population inversion, stimulated emission and laser beam. And type of pumping mechanism used for producing laser light. So we all know that there are different types of laser, that means gas laser, liquid laser, solid laser, semiconductor laser. So we are trying to producing laser light by using different types of pumping mechanism. So these types are very important. First one is optical pumping by using light energy. So light energy transports the atoms from ground state to excited state. The second one is electrical energy. It is very simple. Current electrical energy is converted to light energy. Then finally chemical pumping, gas dynamic pumping. Then the pumping source, pumping mechanics is very important for producing laser light. Then the optical resonator, it traps and reflects photons front and back and forth through the active medium, allowing the stimulated emission to multiply the light and form a coherent laser beam. Finally, the laser beam emitted through the partially reflected mirror side, that optical resonator consists of two mirrors, one side fully reflective mirror and the other side partially reflective mirror. If laser light moving front and back, finally the high energy laser beam emitted through the partially reflective mirror side. This diagram shows that right side, that is laser emitting side. Okay, this diagram shows the absorption, spontaneous emission, then stimulated emission. The first one is light energy absorbed, then the electrons or atoms or molecules moving from ground state to excited state. Then the spontaneously the work is process that is called ordinary light. Then last third diagram shows that the amount of energy transfer from E2 to E1 state through stimulated emission, that means energy transferred through collision. Okay, the energy moving from E2 to E1 state through the energy transfer from one molecule to another molecule. That reaction is called chain reaction. So it converts high energy light beam.